right, ladies and gentlemen, let's put your hands together. And let's welcome our first panel of the day, the 1/6 scale G.I. Joe 3D printing workshop with Jim Egner. Also up on stage with us, we've got Brad Curry and Sean Huxter.
All right. Pull up a chair. It's your show, Jim. Go.
Testing, 1, 2. Can everybody hear me? Check, check, check. Mic check. Anybody hear me? Well, we got no response from the crowd. That's amazing. Does anybody can't hear me? All right. Well, thanks everybody for being here. It's a real pleasure to have these guys on stage with me today. I had no idea they were both going to be here. Sean Huxter's probably been doing this longer than anybody, so I'll let him introduce himself. He's all sweaty. So, and then Brad, here's my major competitor. So we overlap a little bit on some of the stuff that we do. So, I guess we'll go ahead and get started here. Brad, tell us a little bit about yourself.
Well, I'm from background, I'm a manufacturing engineer, tool and die machinist. Started with 3D printing back in 04, 05 when I went back to college to get my master's degree and was a lab assistant in a CAD lab where we had 3D printers. For me, 3D printing is a love-hate relationship.
Oh, yeah.
But my son, who's back there, he all through high school, he was wanting to get into 3D printers. Finally, his senior year, I let him buy a 3D printer. And then I had my first part that I designed and printed was the seat springs for the Johnny West buckboard. So I convinced him to let me use his printer to do that, and then the rest is history. We just kind of continued on with parts from there. So
great story there. Great. Hey, Sean, talk to me. How'd you get started? What's your background?
Let's see. So I work at a computer game company. I worked in video production for a while. Let's just do this. Always loved toys. Grew up with toys. I was the kind of kid that took the toys apart to see how they worked. Loved the Adventure Team, Johnny West, all that sort of stuff. And I always wanted to make toys, and most of my life I was making 3D models for video and stuff like that. But when around 2013 I bought my first 3D printer and started making, real solid toys. And that's, life changed then, because if I'd had 3D printers when I was a kid, it'd be a very different story. The fact that I can think of it and make it is a world-changing thing. So, and I encourage anybody else to try it too. It's great.
One of the things that we've been visiting here a little bit as the show first got started was, how did you get started with it? And what's your background? You come from more of an engineering and manufacturing process. I'm a graphic
tech side.
I'm a graphic designer by trade and an IT manager as a profession, and you're a model video game.
Yeah, so I'm a technical artist for a video game company, which means I take art, make it do things in the game, dragons fly, that sort of thing. And so that's all virtual, right? But now anything I can do virtually, practically, I can do solid now, which is great.
So this turns into, all three of us come from a slightly different perspective on 3D modeling. And for me, my journey began, it's 8 or 9, almost 10 years ago, I guess it was. I was looking for if you're a vintage G.I. Joe collector, and some of you I'm sure are, the 67 Tank Commander had a radio and had a tripod legs for the radio. Well, the radios were pretty common to find, but the tripod legs were nearly impossible. And if you could find them, they were very expensive. And I thought, well, I need to make one of those. And at the time, my son was taking a class. He was in junior high, I think it was, and he was taking a class, a multimedia class, and they were using a tool called Tinkercad. Anybody heard of Tinkercad? Oh, we got some hands raised. Look at that. Awesome. Cool tool. It's made by the same company that makes AutoCAD, Fusion 360. I think they call it Fusion now, but super cool tool. It's designed to be kid-friendly and can be pretty good on-ramp into the world of 3D design. And so I just went crazy with it. And my son, over a weekend, showed me how to use it. It's geometric shapes that either a positive solid object or a hole, and you combine them together, these geometric shapes, into a part. Now, that's a real simple solution. Fusion 360 is its big brother, and then I guess Autodesk and AutoCAD is its bigger brother from that. You use a different piece of software. What do you use, Brad?
Yeah, well, originally back when I first started, I was doing Mastercam, which is a 3D CAD cam system. That's how I first learned to draw in CAD. But I also have taught AutoCAD and drafting with AutoCAD for many, many years. So I used AutoCAD, which is 2D modeling. They do have Autodesk and AutoCAD dropped the bomb going to 3D, but over the years between SolidWorks, I have about 8 different 3D solid modeling programs in my head that I've taught over the years. Inventor was the last one that I really liked, but I've kind of switched to Fusion 360, and now I also use an online. When COVID hit, on the education side, that kind of caused us to rethink how we were teaching, especially with the being able to load software in the computer. So I've kind of switched to Onshape now too, because it's cloud-based system as well. But in my labs, usually we're using Fusion 360 because we can create the files to 3D print, but I can also use those on my CNC machines and generate G-code for my CNC machines as well. So,
All right, Sean, your turn. What do you use?
That's a deep, dark secret.
Oh, here it goes.
No, any program that, like Tinkercad, these things, anything that can spit out an STL file, a stereolithograph file, is a good thing. Anything that allows you to take a shape and put another shape onto it, or cut a shape out of it and blend that shape and mix it, just do that. And literally start with a sphere, add something to it, shape it. There's no limit. Literally no limit to what you can do within the limits of the printer's ability to print something clean. I always recommend try something, start small. Don't expect for perfection the first time. Make something you like, make it better next time. Don't give up because you didn't like the first result. Make the next result better. That's all my advice is.
All right, well, good stuff there. At this point, I got a hand raised. What you got?
Sorry, I was just going to ask if any of y'all have used SketchUp?
Google SketchUp? A little bit.
I don't know if it does the
It does.
It does.
Oh, yeah. No, it's a lot of people start with that.
What Sean was talking about is the file export.
Yeah.
The piece to the puzzle. Let's go back a little bit and talk about the technology that's generally available to a hobbyist. Over in my booth, I brought in an Ender 3 Pro. You can get these at Micro Center for $100. They're a $99 printer. The software that I do a lot of my design work in is Tinkercad, a free piece of software that you can just go online and log in with your Facebook or Instagram account, and you have access to these tools. They all export this STL file format, which is the process that you need. The printer doesn't understand that directly. So there's an intermediate step that you have to go through. So a lot of people will search the internet, find a file, an STL file, an OBJ, I think that stands for object file.
Object file.
There's SVC, that's really more for laser cutting and two-dimensional stuff. But those are the 3 primary file formats you're going to find if you look for files online. But what's the fun in looking for somebody else's work when you want to create your own? That's what we're really here to talk about, is making your own stuff. And for me, my journey began because I wanted something that I couldn't get or was too cheap to pay the full price for. Now, let's be honest, I'm being cheap on this. And the printer is not terribly expensive. You can buy very expensive printers, but to get you started, what you really want to do is basic stuff. Those Enders are kind of an industry. I think you've got one.
Yeah.
They require fiddling. The bed leveling is something you have to constantly fight. If you want to see one in action, I've got one over at my booth printing your crank handle. So by the time we're done here, it'll be ready for you. So actually, that's pretty funny. He had come in. Jeff had come in for a request of a part that I didn't have. And I said, well, if you give me a few minutes, I'll print you one. And so we're actually printing a requested part on demand as we speak. It's over in the booth doing its thing. That's kind of the coolness of this technology. Yes, there are faster printers out there. If you're needing to produce large volumes, 3D printing is not the fastest way to do that. You really have to go into another industrial process called injection molding, and that's really beyond the scope of this panel. But for me, it was, I have a broken part. Well, I break out a tool, wrong one. I'm going to do a little show and tell. Anybody know what this is? calipers, micrometer, I mean, Brad, what's the real name of this?
It's well, that is actual digital caliper. Be
Digital.
careful, they lie to you.
Yeah, they certainly
I
do.
prefer dial calipers
You've heard of
myself.
dial ones? Okay.
Or a micrometer.
This is a cheap Harbor Freight $10 version.
That's the one I use.
Yeah, yeah. And so you literally take this tool, and if you have a broken vintage original part, which I do, a lot of times you find a junk lot and you have a broken part, it'd be cool to have a replacement. You break that out and you start measuring each piece. And in the software, you're actually making things to scale. I found that Tinkercad's pretty accurate.
Yeah.
It's within 1/10 of a millimeter or thereabouts.
The correct terminology is back engineering, so I mean,
yeah.
we're basically back engineering.
Reverse
a lot of
engineering
these-
it, yeah.
Reverse engineering
Yeah.
these parts off of that by taking those precision measurements. So.
Yep, yeah. And so, I don't know about you guys, I think we all kind of hit the same spot. That's the fun part for us for me, is to recreate the parts. For him, is great, these ideas that he's had in his head for 30 years.
Yeah.
Brad?
I'm kind of on the design side too. I mean, my passion is to create my own designs. Of course, there is the business and economic side to it, which we know that all of the collectors like reproduction parts to replace, and we've all got we've got vintage Jeeps out the wazoo that are missing
All
a
kinds
lot
of parts.
And when I started designing like 5 years ago on the vintage Jeep alone, I mean, I'd been a collector since the 1990s, going to conventions and stuff.
Yep.
And I've had my vintage 5-star Jeep since the 1990s too. You don't realize how many parts are actually on that Jeep until you actually start to go through it.
Oh,
So, I
I'm
mean,
missing the gas cap.
Yeah.
Oh, I'm missing the, whatever.
tow hooks,
The tow hook.
windshields, pins,
The handrails, yeah, all of
shovel
this.
holders, so, shovel hook. So.
Yeah. Yes, sir, what you got?
Do you ever use photogrammetry to scan the part?
Oh, I was going to talk about scanning and that whole thing. So I guess we'll switch over here to doing that now. I've played around with every kind of scanning technology that's out there. Photogrammetry is one of them. And in case you don't know what that is, you take a series of photographs, and software creates something called a point cloud, which is a digital representation of that object in 3 dimensions. And if you can collect enough data points, you can actually have a fairly decent scan. The problem with it is if you're scanning a life-size Jeep for parts, you probably can gather enough data points, enough point cloud data to actually recreate that part. But if you're talking about 1/6 scale object, unless you have an extremely high capability of gathering a lot of data points, it's going to be really crummy looking. I've used a couple of different scanners. We have I worked for a university in Nacogdoches. We have an archaeology department, and one of the things that they do is scan artifacts that are dug up out of the ground. And so they've got a $110,000 scanner. It can scan the resolution you need. I mean, down to the micron, it can scan, and that's real.
Come down to Steve after watching what you said.
Yeah, I wish. Honestly, that software and that camera, or the scanner, is really the only thing I've seen that can actually capture enough data to be usable. I've got a Revo Point scanner that I got as a gift. It's a $1,000 scanner, and life-size stuff, it scans fine. If I needed to scan his mug, I could actually probably make a life-size scan and scale it down and actually have a fairly decent recreation. But I can't scan Joe's head, G.I. Joe, the 12-inch G.I. Joe, and actually have anything more than just a really vague resemblance of it. There's just not enough data points with that level of scanner to make a decent scan.
Yeah, and my experience with the scanners has kind of been the same thing. About 3 years ago, I purchased a scanner to kind of do it, but again, it's a resolution issue to get the detail, and it's a different side of the tech and the
man.
technology. So, I mean, if you're using a scanner, it's a whole different skill set to basically be able to manipulate the file and get the file to a point where it's able and ready to be scanned to get good results. So, so it's kind of what you want to do. And for me, with my background in manufacturing, it's just a lot easier for me to just go ahead and draw it up in CAD and produce that as opposed to scanning. Now, I will say, though, several years ago, one of the librarians at the school that I was working for at the time bought a handheld scanner, and we scanned my face. and then I put it into my CNC router, and I machined my face in a piece of wood. I machined 5 of them just solely to kind of put on my kids' bedstand, so when they woke up every morning, they would be able to see my face.
Oh, you're so mean.
I thought it was hilarious. My kids not so
Yeah,
much.
terrified them. They're traumatized there. Now, the scanning stuff, it's getting better. I mean, you can get apps for your phones that do a fairly decent job, but Sean, it's different to have a scan of an object that becomes physical versus an object that you would use in a video game or something like that. Or anything that's going to be just seen on a screen has a different, there's a whole different technology to that. I found that I was spending more time cleaning up the scan of all the crap that you don't need. It would have been more simple to just make it myself in CAD. That's really kind of how it falls out for me.
What if the item's organic, though?
Well, that's when you use another type of software. My skill set, and I think Brad's skill set's more on the mechanical, engineering,
CAD side.
CAD side of things, and I think
The organics is more the sculpting
more of a
software.
and you
so.
use a tool called Blender. A lot of people use that, or Maya.
ZBrush. ZBrush is the one that,
ZBrush, that's a really expensive piece of software,
yeah.
but super cool.
Yeah.
Is that the one you use an iPad for? Then you use a touch pen and all that?
I don't know if they make it for iPad. A lot of my artists at the company I work with make almost all the models in ZBrush, and it's very much a sculptural process. You start with a sphere, and then you start modeling and sculpting and pulling verts and stuff. But as Jim's saying, for something like this, that's kind of pointless because you can make things like this out of basic shapes better, faster, cleaner, and 1/10 of the time.
Yeah.
So scanning. Honestly, though, I'd love to have a good scan of G.I. Joe's face so I can make helmets and things that I know would fit instead of just guessing. But beyond being able to scan something as a reference object to use to make something, I wouldn't dive too deep into scanning myself.
Yeah.
I won a scanner when I first got my 3D printer. I entered a contest and I won a scanner and another 3D printer. I tried the scanner out a few times and sold it. There was no point.
Yeah.
Of course, that was 10 years ago when the tech was low.
Like I say, I got a scanner, and I think I tried scanning what you would think would be a fairly easy thing to scan. That's the Mouth of Doom raft. That's a fairly common thing. It's an organic because it's wooden logs or whatever. It's got a rope that holds it all together. Absolutely beat down. You have to scan one side, and then you have to scan the other side, and then now you got 2 scans. And since there's no reference point on either one of them, how do you get these 2 to line up and bring together? Well, the software that I have doesn't really do that. And then you fight it. You finally get it sort of aligned at some sort of reference point. And now you got all these holes in it because the scanner doesn't see every little detail. And then you wind up having to kind of mesh these things together. And now you've got a file that is so big that you can't print it. The file is too big to do anything with.
And I'll say from that too, I can usually tell on the actual printed pieces a part that has been 3D printed from an actual design part versus a part that's been 3D printed off of a scanned part, because there are missing things in that file that's created from the scanner. So, and that's where I said you really got to know the technology and the software to manipulate what you need if you're going to go the scanner route. And the technology for scanning keeps improving and gets better and better. And for hobbyists, the pricing continues to come down a lot more for the scanning resolution there. But if you're starting out, I still think you're probably better off just going with some type of Tinkercad or Onshape and watching tutorial videos to learn how to draw first.
Last year at the show, there were 2 guys here with they were scanning people's heads to be made into action figure heads. And so starting off with a large size object and scanning that and then scaling it down is definitely doable. You can use your iPhone. I think the 14 and up have enough LiDAR technology in them that can actually do a pretty decent scan of a life-size object. But if you're trying to scan something small, that's not there for the hobbyist at this point. It requires a very expensive piece of equipment to make that happen. Yes, sir.
Have you found an increase in fake parts showing up for sale as original items?
Well, that's a really good question. And when I first got started in my journey of 3D printing, I was making, it wasn't the very first thing I did, which was the Tank Commander tripod legs, but I don't remember now what it was. And there was a guy in New York, and I wish I could remember his name. He says, now, am I going to be able to, in 10 years, be able to identify this as a reproduction or not? And I'm thinking to myself, well, nobody's going to mistake a 3D printed part for an original part, because the way a 3D printer works is it deposits a layer at a time of material, and it leaves these little tiny, no matter how high quality printer you have, you're going to look at it, and you're going to look like it's been printed on a sheet of paper, because that's about the thickness of a layer of resolution that the printers are capable of doing. And so it's going to have these layer lines. It's an artifact of the technology. There's two primary technologies available to the hobbyist. FDM, filament material deposit.
Yeah, filament deposition modeling.
Yeah, and then there's a resin type of printer, and it uses a photoreactive, light reactive resin, and it does those layer lines as well. It's just they're much, much smaller. So if you look at a resin printed part, usually the physical dimensions that you can print on a resin printer are much smaller. The resolution is much higher. But you still have it. So my thinking was, well, nobody's going to mistake one of my 3D printed parts for a vintage part, but I will make sure that I will mark these things with my initial, my name, and a date, if the part was big enough, so that 10 years from now, somebody won't mistake this as, or try to push it off as a vintage part. It'll be clearly marked. And that was not from a vanity standpoint. It was to make sure you could identify it years down the road that this part was, a reproduction. So,
I mean, to get a good reproduction part, you'd almost want to recast the original, right? And that way, that would be more confusing. That'd be harder to tell. But nothing in 3D printing is going to fool anybody, really.
Yeah, we've been fighting the reproduction battle as far as the casting part since the 1990s when Joe became really, really big. And I do mine, I'm kind of the same way because I want to protect the integrity of my original collection and other people's original collection there too. I do Easter eggs, so like none of the parts that I design and sell as repro are exactly like the actual part. So I put Easter eggs in my stuff that I know, and some the top collectors could probably tell the difference between there outside of the layer lines. You know, I suppose in time as the layer lines get better and better and smoother, you might have that issue. At this point, you can still definitely tell a 3D part versus an actual cast molded part. So
yeah. So one of the things I did, I've got a Shapeways store. And I do some small 1/6 scale things there, but they're all original. I do reproduction parts for Dinky Eagles from the Space 1999 TV series.
Oh, I didn't know you did that.
Oh, I certainly do.
That's super cool.
And
Anybody
one of the
collect
things-
those? The Dinky stuff is awesome.
Love them. I've got like a dozen of those. So I've made like new pods that you can't get. I don't do any reproduction pods, but I do reproduction spine because they're hard to find. And I do reproduction side jets because they get lost. And I made an engine that's more accurate than the one Dinky made. But the spine, but yeah, if you buy mine, you can put, you'll have a much better looking engine with the engine bells and all that. And the side attitude jets, you can actually have them printed in metal too. I made the legs taller and more accurate and with the little elbow joint and stuff. But the spine is the spine, and you can't really do any, there's not much you can do with it. So I made it as accurate as the original, but the original has casting holes. Mine doesn't. So I make
That's
sure.
one of your Easter eggs.
Yeah, I make sure that I didn't add that. If I wanted it absolutely accurate, I would have added that. But it's not for accuracy, it's to make your model look good, right? So my reproduction part won't ever be mistaken for an original. And also the way it clips onto the bottom is different as well, so but that's hidden. And no, it's not a recast, it's a redesign. It prints, it's as strong as the original, looks as good, but you won't mistake it for an original.
Yeah. One of the things that, I've started out, and I think Brad did a little bit as well, was recreating those vintage parts. And I started out collecting G.I. Joe. I still have my stuff from when I was a kid. I'm an Adventure Team kid, so I have my stuff when I was a kid, and then when the '90s rolled around and that first Target figure shows up as a 12-inch figure. The first time I saw one of those, I was back into G.I. Joes. And so
Yep.
I've been sort of collecting since the early 90s.
The then and now
That's funny.
set is what did it for me. The then and now set, I got
Yep.
with the original, with the new one and the original. And when I held the original, I said, "Oh my God!" It all flooded back like you wouldn't believe. And I
that's
started
what-
collecting then.
That's what happened to me. And so I collected the vintage stuff, and I was that persnickety, I'm not going to touch it if it's a reproduction, blah, 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 because, I want an only original. Well, that was 30 years plus ago, and a lot of water under the bridge, and prices have increased, and budgets have been cut, and I realized that, making your own stuff was a lot more fun. The design part of it is the fun part for me. I think I said that earlier, but something new has happened to me in the last 2 years, and that's been people have asked for requests. Hey, Jim, can you do blah, blah, blah? I'm like, yeah, probably. So I'll try something new and different. And so I've kind of branched out a little bit, and I've started doing some custom things, which I never thought of myself as a collector making custom stuff, which is kind of super cool. So I've kind of branched off into vehicle modifications. I do the mobile sport vehicle cab tops and trailers and a bunch of other stuff that Hasbro never did. And so one of the cool things that I'm just now discovering, and I think you've been there, and I know you've been there, is what they should have done. And so, Hasbro should have done this, and so.
The word "should" is a great word, by the way.
Oh, man. So
You should have done this.
So the imagination just goes wild thinking of the different things that you can go for. And my biggest limitation, and probably with y'all as well, is time. Who's got time? I work a full-time job. I think both of these guys work full-time jobs as well. So we do this as a hobby on the side. Wow, if I only had 40 hours a week to do
Yeah.
just that, I'd be way ahead of the game. So 3D printing is not a fast technology. It takes hours to print a small object. It takes days to print big stuff. And so, how do you monetize this? Well,
Yeah.
that's a tough call because I don't charge for my design work, but I got to make sure I can recoup some expense and costs along the way as well. So I go for about $1 an hour to print. That's kind of my rate. So.
Yeah, I think that's about the standard rate for most people who are charging for the printing time is about $1 an hour. And if you think about it, actually we probably have similar printers, but like the Jeep windshield for the 5-star Jeep.
We
for
both
me,
make that, by the way.
Yeah, and that, for me, that's about a 11.5-hour print
Yep.
time just to make that. So it's like, so there is that time element. 3D printing is not a fast manufacturing process, so you have to kind of allow for it. And just on the business side, I'd love to do that full-time too, but so far it doesn't generate enough income for my wife to let me quit my day job.
Yeah,
So,
no kidding.
So she's not too agreeable, so.
Yes, sir.
Do you have any do's and don'ts when it comes to your printing?
Oh, do's and don'ts. That's a good question. Let me think on that for just a second here. For me, I was a reproducer, a reproduction, recreator of the vintage stuff. And so one of the things I kind of shied away from were the body parts. One, they were somewhat organic. Even the original figures, there's enough complexity in those shapes, the legs, the arms. I do forearms, but that's it, and the neck post for the muscle body. But those are geometric shapes for the for the body. The rest of it is beyond my skill set. I don't do the 3D modeling that does organic stuff. And so I felt like there were enough spare body parts floating around out there that that wasn't necessary. So I don't know if that's a do or a don't, but I didn't see it as a need. Does that make sense?
I'm fine. Let me rephrase that. When it comes to, I guess, maintaining your 3D printer,
Okay. Yeah. Okay. There's it depends on the printer. I have the $100 printer set up over here. I do almost nothing to it, and it just keeps going. Every once in a while, the print head will clog up. Basically, to understand the technology, you have this material that looks like weed eater filament. Okay, it's very similar to that. It's a little bit smaller in diameter, but think of weed eater filament. And it heats it up to a molten point, kind of like a hot glue gun. And then there's a motor that forces this into the nozzle, and then it's extruded out, and the printer moves it back and forth. That's the process. Now, you're talking about hot and plastic, and eventually there's going to be material in that hot end that's going to break down, and it's going to solidify, and then you're going to have a clog, and then you're going to have crummy prints, and then so you're going to have to stop, and you're going to have to fix that. These low-dollar printers, bed leveling is an issue. The bed is what the print starts out on and is built up from there. And the inexpensive printers don't have an automatic leveling capability, so you're literally sliding a piece of paper underneath the print head and the bed to get the right distance in order for the material to extrude out and then to flow properly. And if you're too far away from the bed, then it won't stick. If you're too close, then you get these other issues. And so there's literally the height of a sheet of paper tolerance that you have to maintain.
Which is 0.003 of an inch. That's 0.003 is about the average size of a slice of paper.
Yeah.
And to put that in reference, if you pull out one of your hairs, the average human hair is 0.003 of an inch in diameter. So just to give you a reference.
Wow, I didn't realize that.
Yeah.
I knew it was paper.
Pull a hair,
No,
measure it.
It's insane. Yes, but
Like between $100 printer and $1,000 printer, is there like mediums in there?
well,
About 500, right?
yeah. There's a kind of a new kid on the block. They've only been around 2 or 3 years. It's called Bamboo Labs. Has anybody heard of Bamboo Labs? Okay, there's a handful of folks here. They make a line of printers starting off at about $300, and they go up to about $1,500. And I'll be honest, when 3 of my Ender 3 printers decided to give it up here 6 months ago, 4 months ago, I bought a Bamboo Labs printer. And it's so much faster than those old printers. It's a game changer for me in the sense that one machine takes up a whole lot less space in my workshop than 3 machines. And so I gained some workspace back and didn't suffer any production delays because they print so much faster. To give you a perspective, that Ender 3 prints at about 50 to 60 millimeters per second. The Bamboo is about 300 millimeters per second. So it's a quantum jump.
Yeah, and that's definitely an increase in the technology. Again, the technology here continues to improve every year. So, I mean, it's just going to keep getting better and better as far as pricing.
One's a $100 printer, the other's a $1,000 printer.
Yeah.
So what's the difference? Automatic bed leveling. It checks the bed level each time. It has LiDAR on board to detect to see if the filament's being extruded properly. It prints a flow rate to automatically adjust the flow of the material coming out of the hot end. It's got spaghetti detection. So if your print starts to print and starts to have a problem, it says, oh, I'm going to stop here. Is this, can you proceed or not? So all of these things factor in. The fact that they can run at these higher speeds makes a huge difference. If your print starts to fail, it starts to print just garbage, and it looks like spaghetti. So they call it spaghetti detection. So fun stuff. But yeah, back to your do's and don'ts. I don't know, from a design perspective, I try not to tread on other people's turf. Brad and I overlap a little bit, but I think we were designing at the same time, coming up with the same.
Well, and I think a lot of
parts.
that, I mean, we've been doing this now for like 6 years plus, and a lot of that came out of just people requesting different stuff and paying attention to what everybody was doing. About 3 or 4 years ago, I had told my son we needed to start kind of going into some of the 3 3/4 inch parts and be doing that. But again, it's a time to do it. Of course, now the 3 3/4, there's guys out there that are doing the 3 3/4 inch models, and now you got the 6 inch with the classified. So you got people that are doing the classified. So, back when we started, there was only a handful of us that were doing all of this, and now it's blossomed. There's a lot more people. Again, the technologies came down. The use has definitely been a lot more friendly. So like one of my do's and don'ts, if you're mechanically oriented, You know, some people get very frustrated about leveling beds, and I think that they just don't quite have the mechanical aptitude, so that kind of is frustrating for them. They give up a little bit. So if you're mechanically oriented, definitely kind of start with that. If you're not, then save up and buy the more expensive printer to start out with, where it gives you instant success. You won't be quite as frustrated with it. As a tool and die machinist, for me to sit there and level beds and pick up offsets and stuff is not a big deal, so I never really had any problem. But I know a lot of other people that got frustrated with that really early on, so.
Generally, you only got to do that every now and then, right?
Yeah,
So
yeah.
you level a bed, and it's going to do a lot of prints before something jars it or whatever, or it just falls out of alignment. So it is a process. Everyone's got to do it, but once you do it once, you're good for a while. And it's the same with maintenance of the printers. I've got 4 running almost all the time, and those could be running for days and even a week or more without any one of them having a problem, and then one of them will. And so you turn that one off, you try to fix it, but you let the other 3 do their thing. I've got 10 of them, so I could just swap one out. But when it comes to the maintenance itself, it's a rare thing generally. Every now and then I'll have to take one up to the bench, open it up, replace a gear or something. Some of them are even 3D parts that are printed with that same 3D printer, which is kind of cool.
Make its own self.
The thing I find I'm replacing most on mine is a little gripping thing that grabs the belt that pushes the bed back and forth, and it gets a little loose because it's a 3D printed part. And so I printed up like a dozen of those, and every time that happens, I just rip it apart, grab another 3D part, pop it in there, print another one. And so yeah, maintenance, I got into the hobby to be a designer, not a maintenance guy. And then some people, literally some people I know, got into the hobby to make the printer, maintain the printer, but they never used the printer.
Yeah.
I know a guy with a full basement. He's got a massive CNC machine. He's got all this stuff, and his hobby was putting those together. I don't think he's used them at all.
Yeah, there are other maintenance issues too. I mean, so you will eventually in time, as the maintenance on, depending on which style you go with, you know, in the last month out of the machines I had, I only had 2 that were functioning and 4 of them that were kind of sitting there that weren't working anymore. And so I spent this past week basically ripping apart the machines, unwiring and replacing the thermistor, what's called a thermistor that helps control it, replacing some extruders.
It's like a temperature sensor.
Yeah, temperature sensor and stuff. So, I mean, there is maintenance on the lower cost machines, but from the electronics board, I mean, most of it's pretty simple wiring. You can, you know, you unscrew it or plug it in and put it in. So it's not that technically difficult. But for some people, they like that. Other people don't. So it depends on what you like to do.
Yes, sir.
Y'all touched on it a little bit, but for your 3D models, do you find, is it effective to change the scale and still get a good print out of the new scale, or is it?
Oh, man. Look, Sean wants to handle this one.
I'm set up to answer this one.
Go ahead.
So the first project I took on for G.I. Joe stuff when I got my first printer in 2013 was this aerial drone. This aerial drone I designed for a set that I brought to the 2014 show and showed, which is Save the Endangered Pygmy Rhino, which Cotswold, for this year, we made for the 10th anniversary, Cotswold and I got together with costume makers and made a set, which is out there at his booth, so you should pick one up. This drone is, I think, about 2.5 inches wide, something like that. The legs fold down, and the camera rotates and pivots. And Greg said, can you make this fit one of my backpacks, which is a kind of reproduction G.I. Joe backpack? And so I said, I think so. Well, I've never tried it before. So I took this and I made 4 versions, 75%, 66%, and half. Every one of them worked. All the legs worked. They didn't look as good that small, but I literally slammed it together exactly the same way. The legs folded out exactly the same. And so what we sell now through Cotswold is usually the slightly smaller version of this, but this one started out at this size. The jetpack, the Helijetpack, was designed for a 1/6 scale figure. And last year, I went to Toylanta, and Super Joe was kind of taken off. So I thought I would try scaling it down to Super Joe, which is a 70%, I think, 70% of the size. And everything worked just as perfectly as it did here, with a couple of minor exceptions. The harness was too thin and flimsy, so I had to beef that up. And his hands aren't very flexible, so I had to change the control sticks. Other than that, these are exactly the same parts, printed at 0.7.
Now,
and
did
it
you
works
change
fine.
that in CAD, or did you just tell the printer print at 70%?
The first prototype was I told the printer to print at 70%, because why would you bother, right? Why would you go and after that, I took all the parts, scaled them down, and then I started adjusting the few parts that I needed to, so now that's its own separate set of files. So I don't have to remember, was that 70 or 75%? Don't have to worry about it.
It's
But
just a new part now.
so the interesting thing, and why I was a bit surprised, is that when you design parts that move, you have to have a space tolerance between the parts, otherwise they jam or they're too loose.
Yep.
And when I imagine my surprise when I took this down to 3 different smaller sizes, it all just
The
worked.
tolerances were maintained and everything worked.
Which is,
Yeah.
shouldn't have happened, really.
Yeah, no, it shouldn't.
Those tolerances kind of have to stay constant while the scale is scaling down, but it worked. If any major work, you're going to have to go in and adjust those tolerances, but otherwise, yeah.
One of the things Brad does is something called the grabber claw. Everybody know what that is? That's Adventure Team.
Demolition stuff.
Demolition stuff, yeah. And it's an articulated, like, long-reach clawed wire pliers looking thing. And you print that in place, don't you?
Yeah.
So his has pins and pivot points and that sort of thing, and it's all printed in one shot. And he's got his printers dialed in enough. Mine I can't do this way. He's got it dialed in enough so that you don't have to assemble it once it's finished printing. You just peel it off. It's pre-assembled. It's printed.
Sometimes that works.
He
sometimes.
revealed a secret here. Sometimes it works.
And
yeah.
sometimes you have to do it assembly-wise. But yeah, there's that possibility too. When you're talking about the scale, and this will be my drafting teacher side coming out in me.
Here we go. Here's a lecture.
Yeah, when we draft, we always draft in scale 1-to-1. That's life size. Whatever it is in real life, that's the size you draw. So 1-to-1 scale. Now, that doesn't always work when we're trying to make toys and stuff. So usually when I do my design, I am drawing 1/6 scale, but it's 1-to-1 what it would be. So if I have something that's life size, like right now I'm working on a couple of things where I'm taking some old World War II objects, and they're life-size World War II objects. I'm taking all my measurements on it, but then I divide that measurement by 6 so that I do it. So when I draw in CAD, it's a 1/6 scale version of that. Now, if you're talking about thicknesses, like, if you talk about 1/8 of an inch, 0.125, if you need, at 1/6 scale, it measures 125 thousandths. When you scale it down for 3 3/4 inch, that's 1/3 of the size. So 125 thousandths basically becomes about 35 or 40 thousandths. Well, for FDM printers, now you're really kind of at the edge of
the
what they can
resolution,
actually
yeah.
do. So then you're going back in my CAD system, I can kind of take my 1/6 scale version and produce a 1/18 scale version, but then I have to go back in and say, okay, well, that particular dimension only comes out to be about 20 thousandths of an inch, and it's going to fail. So then I have to go back and beef that up and change the model at that point. So I mean, those are all tricks of the trade that you learn in time, and we could probably get into the orientation, print orientation too. When I first started printing, sometimes, because of the layer lines, structural integrity of the part and strength of the part, things would snap real easy. So then you start to really learn about orientation of how to put it on the build plate, how to print on the build plate, so that it actually gives you a little bit more structural integrity and strength behind that too. So
Yeah, horizontal layers, for a tube, for example, a thin tube, if you print it vertically, it's going to snap like a twig. But if you print the same thing horizontally, those layers are really strong. So you could bend that thing, that's not going to break. But then you suffer visual quality because you're getting horizontal lines across your cylinder instead of vertical circles, which look much better in a cylinder. Once you get past a certain thickness, though, you don't have to worry about that. It's really hard to break these things once they get past, like, half an inch maybe.
Yeah.
Maybe even smaller than that.
And you do something on some of your stuff, like inserting metal rods and pins and nails and that sort of thing.
Yeah, so when I did the 30th anniversary jetpack, it's Hasbro's original concept had moving joysticks, but the production models don't. The one they produced had just static sticks. If I were to print those sticks vertically, I would worry they'd snap off and I would never sell it. But we made them to move, and what I did is I printed the thing exactly like the Hasbro one, but it was hollow inside, and I took a finishing nail up through the joint cylinder into the handle, and so it reinforced that handle, and you can't break that. Even though it was printed vertically, you would snap it like a twig. Just putting something inside of it like a rebar. It's just
Yeah.
like a rebar.
Reinforced.
And it reinforces it so you can't break it. And that's a useful thing to do as well.
Yeah, yeah, and you start to learn different tricks. You learn. I'm going to give a shout out to Aaron Luck too, if some of you might know Aaron Luck from Lucky Shot. For years, like if I was doing different weapons, of course I would make my model and then try to print the model complete. And you always get the different layer lines, or you also get the support material that leaves marks too. It's like, yeah, it's kind of nasty looking. Well, I think it was about 3 years ago, I was down at Jolana with Aaron, and Aaron was like, well, why don't you just split it? He was like, I split all mine in half and print them in halves, and then glue them together. And it's like, that was a game changer for me too. So that's just kind of learning from other people that are doing it too, on how to kind of get around some of the things that you don't like when you're seeing. So talking
I was
about
a bit
do's and
surprised
don'ts.
there as well. I talked to Aaron down at Toylanta last year, and I looked at his guns and stuff, and I said, how are you printing that? He said, oh, I'm printing in half. So they put them together.
Yeah, and then he glues them together.
But he's done them so perfectly, you can't tell.
Yeah.
Wow.
No.
That's something I played around with and not very good at. Yes, sir.
Is it easy to clean up? Like, I'm into slot cars and the guys will make bodies and stuff.
Yep.
But it has all those, whatever you
Support material.
Support
Yep.
material.
Yep.
Is it hard to clean those up, or do you take a hot knife?
Well, there's a couple of tricks on that. Part of what you learn when you're 3D printing is there's
Have lots of
different-
Band-Aids.
Oh, man, if you look at my hands real close, there's skin missing. There's different types of support materials, and one type is called organic or tree support, and it takes a little bit longer to process on the computer side, to slice the file up to make it so that the printer can understand it. But those type of support materials are much easier to remove. A lot of it has to do with the quality of your printer, how level the bed is, and what your settings are on the software that slices the file into something that the printer can understand. You got to understand these STL files that Sean was talking about. The printer can't do anything with those. You have to slice the file into the layers, and that's a whole nother piece of software that does that. Another free piece of software, a lot of people use Cura, some people use Prusa Slicer. There's
My
a bunch of
printers
different-
do it automatically. So I will send a file to my printers, and when you hit print, it does the slicing for you, figures out its own support, and then prints it. So I don't have to deal with that, but the resin printer doesn't. You got to figure out, you got to make those
You gotta
supports
go that.
yourself, and that can be a
Resin
major
printing.
pain.
Yeah, that's a
Yeah.
big thing.
Be prepared to break a lot of parts to begin with as you figure
Yeah.
out the best
And a lot
way
of-
to
and a lot of
support it.
skin.
And that support material is crucial. One of the
Can't print without it.
Yeah, years ago. Well, I do a project where students, high school students, will design one of the buildings in town, and then we will 3D print, kind of like a model railroading type thing. And they're hollow because they got to build the wall structure. They have to do the floor plan and everything with it. And of course, when I first started doing these, all the support material, and we're making like little either N-scale or HO scale houses for these things. Students love to do it, but it'd take like 20 hours for students to print one of these. Well, I got a class of 24 students. I can't have each one of them take 20.
All year long to print that.
Yeah, so then we basically started to play around with like tree supports or other type where you had less support and it would take less time. So a lot of that is playing around with your slicer, kind of trying to see, and then you print, hey, did the print fail or did it work? And when it works, it's great. When it fails, then you're cussing it out and having to go back and say, okay, now I got to wait another 6 hours before I get another good
Yeah,
part. So-
I've got a box of failed dreams in my booth. We were told we had 45 minutes. We're coming up on that time slot there for the next bunch. Does anybody have any other questions they'd like to ask? Yes, sir.
On your commercial side, you guys have to worry about licensing.
Okay. I talked to several folks with Hasbro on this once upon a time. Basically, my understanding is Hasbro's basically abandoned the Adventure Team stuff. And since they're designed by me by hand and produced by me by hand for small quantities, like a convention or somewhat, Hasbro doesn't really care.
Are you talking about that type of licensing, or are you talking about software license?
No, just that from Hasbro.
Okay, yeah, he answered that too. I will tell you, on the software side, if you are, most of the free software that you're looking at is a non-commercial license. So you could, if you're going in and you start to sell, I do pay for my licenses, which that is a cost that goes to it. if you go in and you start to produce and create models and then go commercial, it is always a possibility that the company could come back and cut you off. I like Onshape. And I like it because my students don't have to download software. They don't
all
have to have a
online.
computer. They can do it from wherever so long as they have internet access. But the downside of that for those students, and I always explain to them, is they don't really own that. I mean, it's Onshape's server that's there. So I
You
mean,
lose the internet, you
yeah.
lost your access to your software.
Yeah,
you know.
and it is, when they sign up for that, it is with the understanding that this is not for commercial use. So if you're a hobbyist doing stuff for yourself, there's no issues. As soon as you decide you want to go into business, there could be issues.
I can answer that question better for you.
Okay.
Okay.
From, run the Collectors Club,
Yeah.
okay, this would come up all the time. So in the Hasbro sense, a couple things is, one, you only have to worry about IP if you're using the logo. It's just the words. That's all that's filed or marks that they have. Anything else that's out there, whatever, because you redrew it, you did it, it's your file. Second piece of that is, they don't care. There's nobody paying attention to any of this anyway. And even when they did pay attention to them, part of our contract was to turn in anybody we saw using the IP. So if we turned them in, you might get a cease and desist letter first. Probably not. The other thing about Hasbro is the way they do the funding, they actually don't have any legal funds for IP protection.
Yeah.
So it comes out of the brand team's budget, and the only ones I've ever seen them fight is when URLs first came out, somebody came out with the URL of Candyland, and it was not candy, okay?
Okay,
So they went
not
after
surprised.
that. And then the dumb one they went after was, because when you file a mark, it has to be filed in a category. There was somebody came out with a Transformers computer. They went after them. Well, guess what? You don't own the mark in computing, so they lost that whole that whole battle. So my answer would be, forget about it.
I see Greg came in at the very tail end here. He must be getting ready to run us off here. So, yeah, he's telling us to wrap it up here. So does anybody else have any questions or thoughts for us?
I was about filament and where you market it or get it from, and are there some better than others?
Yes, there are quality brand filaments, and then there are discount brand filaments. I don't buy the Hatchbox. I don't buy the Overture, the Amazon brand stuff. I
I
prefer
buy a lot of Hatchbox.
Yeah, I do a lot of Hatchbox.
Hatchbox is great.
I've had nothing but problems with it. So I use, there's a company called Paramount.
Oh.
And I really like their filament because they have the colors that are very military. They got the khaki and the olive drab and the Air Force blue and all these other colors that are really close to what the vintage Hasbro colors were. So I use a lot of Paramount.
And you do get variation even from same manufacturer
Yeah.
sometimes, like, so, because I use Paramount too. When I first started using a Paramount, which was like 4 or 5 years ago, I would get some deviation from one spool to another. That would go, again, their quality control has gotten better and improved as well. I've tried Sunlu,
Yeah,
which was,
Sunlu.
I've never had any success, but then you talk to other people and they're like, well,
So that's what I
have,
use.
I have great,
You use
great
Hatchbox, I
success
use
to it, so-
Sunlu for my yellow.
Yeah, so I mean, it all depends. So experiment, try it out.
And stay with what works.
Yeah, there is a U.S. brand called Philocube. They're out of Texas. So, nice to support Texas folks, and their colors are pretty good. So, not had any problems with them. Bamboo Labs makes their own branded filament for their bamboo printers, and they have RFID chips in the spools themselves. And so you just load them into the printer, and the printer knows what color it is and how much material's on there and all that kind of stuff. So that's kind of cool.
Last thing for me on do's and don'ts is don't get a MakerBot.
No, those are terrible printers.
Yeah.
I'll give you a do and don't. Do try, don't give up.
Yeah.
There you
Oh,
go.
that's a good one.
That's a great one.
All right, well, thanks, everybody.
Thank you, appreciate it.